Hi everyone, welcome back. Today we are solving find all people with secret. So the problem tells us that we are given an integer n, which just means the number of people numbered from 0 to n minus 1. And we are given an array called meetings, where in each meeting it will be an array of 3 elements. And the first element is the first person, the second element will mean the second person, and the last element will mean the time that the meeting took place. And there will also be a person called first person and person 0, and they will always share the secret at time 0. And then this secret will then be shared in every time a meeting takes place with the person that has a secret. And this is also important for an edge case that I'll go over later, but we need to know that the secrets are shared instantaneously, which means that a person may receive the secret and share it with people in other meetings within the same time frame. Now finally, we want to return a list of all the people that have the secret after all the meetings have taken place. So if we look at this example, these 5 people have the secret because in time 0, 0 and 1 has the secret, and at time 5, 1 can share it with 2, and at time 8, 2 can now share it with 3, and finally at time 10, since 1 has a secret, he can share it with 5. Now if we look at this example, 0 and person 3 have the secret at time 0, and now at time 2, neither 1 or 2 know the secret, so no secrets were revealed. But at time 3, 3 shares the secret with 1, so 0, 1, and 3 have the secrets. Now in the last example, at time 0, person 0 and person 1 have the secret, and at time 1, 1 now share the secret with 2, so now 2 also has the secret, and also 2 can share the secret with 3 at time 1. So this tells us right here that the secrets are shared instantaneously, meaning the person can share the secret at the same time as they have received it. And finally at time 2, 3 shares the secret with 4, so all these people have the secret and we return them. So now that we have seen some examples, let's get to how we can solve this problem. So one edge case that I want to cover is that hypothetically, let's say in this example, before time 5, only person 1 knows the secret. Then if we look from the top first and we're like, okay, 2 and 3 no one knows, pass through, 4 and 3 no one knows, pass through, and we will say that only 2 got the secret, but that's actually not the case. If we look from here, 1 can pass to 2, and 2 can pass to 3, and 3 can pass to 4. So what we will need to do is we can make an adjacency list, and then we can search it through with depth first search. So what we will do is we will use a secret set to keep track of all the people that have the secrets, and times will be the adjacency list, where the keys will be the time that it actually occurs, and the values will be the people that are involved in the meetings. So we will have to search through the first time to get to set up this times adjacency list, and then we can use depth first search through each event in times, and through each time we will set up a temporary visit array so that we don't have to do repetitive steps. As soon as we see a person, we add it to the visit set, and we will look in depth to see all the person that's caught the secret at that time. And by the end of the iteration, then we can return the secret set as a list. And by the way, if you're not familiar with depth first search, feel free to look it up first, but basically what we're doing is looking through one person and then see who he shares a meeting with, and then we will search through the person he shares the meeting with, and so on and so on. Then we will look at the next person, and then we will continue after we have searched through all the depths at that time, and then we will do the same for all the other times as well. So let's go through this example real quick. So at time 0, 0 and 1 has a meeting, so we will add these 2. Person 0 and person 1 knows the secret, and now we will set up a times adjacency list. At time 5, 1 has a meeting with 2, 2 has a meeting with 1. We will set it up both ways because the first person or the second person can both be the one that shares the secret. That's why we have a visit set. So if 1 goes to 2 and then we get to 2, and 2 gets to 1, but 1 has been visited, so we can just skip it. Anyways, we will continue iterating. Now at time 8, 2 meets with 3, 3 meets with 2, and now at time 10, 1 meets with 5, and 5 meets with 1. And now we will do a depth first search on each time, and we need to make sure the time is in sorted order. So luckily it was sorted this time, but if it's not, we will have to sort it according to the times. So first we will look at visit, and the first person we will search through 1, so we add 1, and 1 shares a meeting with 2, so now we look at 2, and since we visited 2, now we know that 2 knows the secret, so we add 2, and 2 shares a meeting with 1, look at 1, it's already in visit, so we can now complete this search. So now we look through time 8, and of course we need to clear the visit set first before that. Look at time 8, we see person 2, add 2 to visit, and 2 is already in secret, but we can look at person 3 because they share a meeting. So 3, add 3 to visit and secret. 3 shares a meeting with 2. 2 is already in visit, so we can move to time 10. Now we add 1 to visit, even though it's already in secret, but it shares a meeting with 5. So now we can look at 5. Now we know that 5 knows the secret, so we add 5 to secrets and we add 5 to visit. Look back at 1. 1 is already in visit. So now we have officially finished this example and we can return this as a list as our result. So the time complexity would be O of m log m, where m is the number of meetings. Because of this times adjacency list, we will have to sort it, and that would take the most time, so it would be m log m. To be more exact, you can do O of n log m plus m, because we will have to first set up times first and then do the sorting. But obviously this is smaller than this, so this will cancel out, so we can just simplify to O of m log m. And the space complexity would be O of m, because this times adjacency list will depend on the number of meetings that there are. So now let's get to the coding part. So first we will set up the secret set. So in the beginning, only 0 and first person knows it. So we will contain person 0 and first person. And we will initialize the times adjacency list to an empty one. And then now we can set up the times adjacency list. So we will look through the meetings. We'll call guy 1, guy 2 as the 2 people in the meeting, and T for time. So if T is not in times, then we would set up times of T as a default dictionary. And then now we will add guy 2 to guy 1 and add guy 1 to guy 2 at that certain time. Now we will add guy 1 to guy 2. Append guy 1. And now we can set up our depth first search function. So define DFS guy 1 and the time. So if guy 1 is already in visit, then we can return. Otherwise, we need to make sure we add guy 1 to visit, and we can also add guy 1 to secret if it's not already in secrets. And now we will look through all the people that guy 1 shares a meeting with. So for guy 2 in time of guy 1, and DFS guy 2 through time, so we search through the depth. And now we will look through the times in a sorted manner. So sorted times dot keys. And for each time we initialize visit to empty, so empty set, and then we will look through guy 1 in times of T. If guy is in secret, meaning he knows the secrets, then we can see who he can spread it to through the depth first search function that we defined earlier. And finally, we can return the secret set as a list for our result. And let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section. And I hope to see you all again soon.